Okay, so my name is Soujanya and I'm from Singapore University of Technology and Design, SUTD, government-funded public university in Singapore. This is our lab, Declare, Deep Cognition and Language Research. Today, we will be discussing about this paper basically, which outlines the new directions and the challenges on challenges of sentiment analysis research. This paper I co-authored with my PhD student Dave, my colleague Navonil, and Rada from University of Michigan. So a few notes about this paper. Basically, what I wanted to say that if you are looking for a survey paper, this is not really a survey paper, and this talk is not going to be a review of the past approaches in sentiment analysis. So if you are interested in getting intuition for your next paper on sentiment analysis, welcome on board. If you are interested in the new directions in sentiment analysis, of course you are welcome. But if you are interested in just reading the surveys past works, you can check this GitHub link, this GitHub link, and you can find all the relevant survey papers there. The Saif from NRC, Canada, and Bing Liu, they wrote fantastic survey papers on sentiment. So you can, of course, read those papers. So just to reiterate what I was telling, so our main intention through this work is to draw attention to key research topics within the broad field of sentiment analysis and identify critical directions, okay, which are under or unexplored till now. Okay, so what is sentiment analysis? So if we just quickly move to the definition of sentiment analysis. So it's basically if you have unstructured content, you try to understand the underlying sentiment of that. Okay, so in this example, it's a very simple example. So if we want to define sentiment, what do we have? What information we have here? So we have John, which is the opinion holder. We have opinion award, which is dislike. We have two things on which the opinion is being expressed. One is the aspect, which is camera, and one is the entity, which is iPhone 7. So if someone asks you what is sentiment analysis, you can take an example and define sentiment analysis in these 4 different categories: entity, aspect, opinion holder, and opinion award. And of course, the overall sentiment towards the entity or aspect, that is here negative. Okay. Now, key milestones in sentiment analysis. Sentiment analysis till now has been researched quite a lot, like extensive research have been done on sentiment analysis. So if we start from the foundation, 1994 and 1999, the analysis of private state and subjectivity analysis. So what does it mean? That you take a sentence or take it unstructured or text document and try to analyze whether this document contains private state of the speaker. Okay, if it expresses in a private state like opinion, sentiment, emotion, then it is subjective. So that means it contains sentiment. And if it does not, then it's a factual sentence or it's neutral. Okay, now there are quite a bit of works, like if you can see that in 2004, 2006, those era valence shifters, like whether you are, there are sentiment keywords shifting the sentiment of a sentence from one phrase to another. Then there are lexicon era, like where the sentiment analysis used to be carried out using sentiment lexicons. Like you have a lexicon which contains positive and negative labels to assign to the words or phrases. And sometimes these lexicons are also used in the supervised framework by, you know, by assigning some feature values to these lexicon words. Okay, so then the sentiment analysis field started growing very fast when with the advent of RNTN, deep learning. So I would mention two primary works here. First, the RNTN, recursive neural tensor network, and the CNN, 1D CNN, basically by Kim. So these two works completely boosted the performance of sentiment analysis system and how it changed the definition, like changed the way how we used to do sentiment analysis before 2013 or 2014, that period. Then in the modern era, if you can see that the contextual language models came, ULM-FIT, BART, this kind of works, ELMO, which rely on the contextual word embeddings, and then initialize the sentiment words, you initialize to do sentiment analysis, you initialize the text with those contextual word embeddings, and it completely changed the era of sentiment analysis. Like the result jumped from it, we will come to it later also. The results on sentiment analysis jumped from 85 to 96%. Okay, after these models came. Okay, so what about the past? The past is about the early sentiment analysis, like as we already explored, subjectivity, definition of subjectivity, affect. Then it's about the different granularities, for example, the document level sentiment, sentence level sentiment, and aspect level sentiment. Then there are major trends which we could see in the past, like rule-based, lexicon-based machine learning, and deep learning. So these are the two nice frameworks that completely changed the field of sentiment analysis. First is the RNTN, like you obtain the parse tree of a sentence, you convert that tree to binary form, then you recursively calculate the value of sentiment in each of these nodes. And finally, you predict the sentiment at the top level. So this is the recursive neural tensor network based on the compositionality of the sentence. Okay, I'm not going into too much details about this RNTN and 1D CNN because you can already read their papers. There are many nice blogs, tutorials, YouTube videos regarding that. And 1D CNN, we all know about it. In fact, we all use it in most of our papers as baseline. It's by Kim. It's simply you, instead of image where you conduct 2D convolution, you take text and you conduct 1D convolution. And it's just you utilize CNN, one-dimensional CNN to extract features, and then you classify using logistic regression. Okay. Then yeah, the contextual models came like BART, OpenAI, GPT, ELMO. These things take the whole sentence as an input, and using BiLSTM based language modeling or BART next sentence prediction objective, they calculate the word embeddings, contextual word embeddings of the sentence, contextual word embeddings depending, like it varies from one sentence to another. So if you have a word, if you have a word containing in sentence S1, you send to BART, the embedding you get for that word will change if you slightly change the context. So it's contextual word embedding. Okay, so next. Now the question is, how have we achieved true sentiment understanding yet? So we saw the performance boost on the standard benchmark data sets, like if you see this graph, you will observe that on IMDb, on sentiment tree bank, binary sentiment tree bank, 5 classes classification, or semival, we have reached, the result actually boosted quite a lot. Like even if you consider IMDb after 2011, now you have 97.4, a jump from 88.89. And for the case of SST2, 2013 RNTN got 85.4, and now you have 97.4. So okay, so fine, we have a big jump in the accuracy, in the performance, but do you have a clear, do you have a clear understanding of sentiment, like true understanding of sentiment? You know, the lexical, syntactical, and contextual features that we say that important for sentiment analysis, we knew it before. Like in 2002 Pang's paper, if you read, you will find that these features are important for sentiment analysis. Today we have BART, and of course we can get better result because it is rich in its architecture, it is novel, it gives you better features for sentiment analysis. But we are really still far from achieving a true sentiment understanding. Why? Because you know, if we do not really understand that why we express a sentiment, like if you say that John dislikes the camera of iPhone 7, but if you fail to explain that why does John dislike this phone, that is the sentiment reasoning, you really do not understand the true sentiment that exists in this sentence. Similar for the other things, like sentiment based dialogue generation or the motivation behind an expressed sentiment. So these are all the directions that we should focus on. Okay, so now our statement in the paper was this: so as members of this research community, we should strive to move past simple classification as the benchmark of progress. Like we have these datasets, sentiment tree bank, like IMDb, we already obtained 98% result, but these are the simple classification step, the classification problem. So as members of this research community, we should not just consider this as a benchmark of progress. Instead, we direct our efforts towards learning tangible sentiment understanding. What does that mean? That means that we analyze, customize the training architectures of the context in the context of sentiment. So you have BART architecture, you of course take the contextual or embeddings, but you try to use these embeddings in a manner, in a particular architecture that is tuned for sentiment analysis. Or along with that line, you do more like multimodal learning, sentiment reasoning, sentiment aware natural language generation, like that. Okay. Okay, so if you can consider this conversation between a user and a bot. So why I give you an example of a conversation? Because a conversation is a complete NLP toolbox, right? So once we generate a perfect conversation, that means that we kind of have a complete NLP package. Like you have co-reference resolution, you have entity recognition, you have relation extraction, you have generation capability, you have sentiment understanding. Like everything is involved in in conversations. So in this particular example, if you take a closer look. So this is the sentence of the user. Now, to understand this sentence, what can we extract? So that the sentiment is expressed on what? Two aspects, airline and service. Who is expressing? The user. Okay. And why? Like the sentiment reasoning, this. Okay. Now, you see that from this sentence, the next sentence completely changed because you now have a different sentence. Okay, different sentence coming from a sentence coming from a different language other than this. Okay, like this language is different, right? Now, two problems are here. So first is that this is a code mixed sentence. So that means that you have an extra level of complexity, that you now have two languages mixed in a sentence. So you need to have different models to analyze both of these. Okay. Now, if you consider this sentence, the translation of this sentence is the best in the world. So that means this sentence is also sarcastic. So you need sarcasm detection to understand this utterance better. Okay. Now, based on this contextual clue, what the bot can generate? The bot generates this. So that is the scope of sentiment or energy. Okay. So in this example, we show you that what are the different tasks involved in sentiment analysis. It's not just you classify sentiment into positive and negative and neutral. It's not a mere KOA classification tasks. You have a lot of things to do. Okay, great. Now, this is in our paper. This is what we think. This is what we think the future directions in sentiment analysis. I would not go into the subcategories now, the subcategories in detail now, but I will cover all of them later. So just to stay at the second layer of this hierarchy. So we have aspect-based sentiment analysis, we have multimodal sentiment analysis, we have contextual sentiment analysis, sentiment reasoning, domain adaptation, multilingual sentiment analysis, sarcasm analysis, sentiment over NLG, and bias in sentiment analysis systems. Okay. Okay. So now, first, aspect-based sentiment analysis. Now, if you consider this sentence, the actor is the only failure in an otherwise brilliant cast. So, suppose I am writing a review on a movie. So now, if we encounter this sentence, we have what we have. We have this opinion holder, which is actor. Now we have, pardon me. So we have the opinion holder, which is user. Now the opinion is being expressed on actor and cast. These two are the aspects. Now, if you see that two different sentiments are being expressed, brilliant on cast and failure on actor. Okay, this. Now this is aspect-based sentiment analysis. If I give you a sentence and if I ask you that what are the different opinions expressed on the aspects, the job is to return with the corresponding aspect sentiment score. Okay. So now what are the different new directions or future directions that are unexplored in aspect-based sentiment analysis? I mean, there are some data sets called semi-failed data sets, and people are doing the aspect-based sentiment analysis, but there are more to genuinely have a true understanding of aspect-based sentiment analysis. Okay, so first is the aspect term categorization. Now, if we consider this hierarchy, see the aspect phone. Now, phone has multiple divisions like screen, processor, and network. Now, you can further classify the screen, processor, and network into these subcategories. Now, if I give you a sentence, S, okay, and in the sentence you find this signal quality. Now, suppose you are working in a company like Samsung, and your manager asks you to mind the corpus or mind the reviews that Samsung Mobile receives, and you just give your manager the sentiment on signal quality, but your manager is very busy, and to understand it, he or she really needs to understand the whole hierarchy. So how do you do that? You would map signal quality to network, and from there, phone. So you will need to present an ontology of your aspect hierarchy, that signal quality belongs to the category of network. So a user is expressing some negative or positive feedback about the network, and of course the network belongs to the phone. Okay, So then you annotate with the corresponding font. So these kind of things are very important when you work in an industry. So in our only a very little amount of research been done on this, because on the semi-val data sets, I think there are just, yeah, there are just two datasets available, semi-val 2014 and semi-val 2016, where these aspect categories are available, but they are not available for other domains. And I believe that, you know, based on my communications to my industry collaborators, this kind of application is a need of the hour. Okay, we go ahead. Now, implicit aspect level sentiment analysis. So this is very important. So you will not see examples where the sentiment is being expressed explicitly. Okay, there will be cases where you need to infer the sentiment of a yeah. Should I turn on my video so to make it more interactive? Any comments, or is it just fine? Any comments?
No, it's fine.
Okay. So aspect-based sentiment analysis, implicit aspect level sentiment analysis. So what I was telling, that not every time the sentiment is being expressed explicitly. So and sometimes you need to infer the sentiment from the surrounding context. So in this example, if you see that there is this sentence: crazy Republicans voted against the bill. Now, if you do not consider this part of the sentence and you just consider this, what would be your what would be the output of your aspect-based sentiment analysis system? Like it's difficult, right? That Republicans are crazy, but they voted against the bill. No way we can infer, like we as human being can infer still that, you know, if you call Republicans as crazy, they voted against the bill, so there's might be something different sentiment expressed in the sentence. But once you encounter this sentence, oh no, that means you are sad that someone voted against the bill and you are really sad about it. So you can, from here, the sentiment flow to this. Okay, this kind of implicit aspect-level sentiment analysis is difficult to do, and not many works really focus on this. And also the data sets, there are no data sets that clearly indicate this kind of nature, this kind of sentences. Like, it would be great to have just 1000 examples of such sentences, and we create models to predict sentiment in such complex scenarios. So if we see the speaker expresses her or his negative sentiment on the Republicans explicitly, by doing so, we can infer that the speaker's sentiments towards the bill is positive. So as you see that on the Republicans, the expressed sentiment is negative, but on the bill, it is positive because you infer from here. Okay, and also the crazy somehow helps in the inference as well. Okay, so now aspect term polarity co-extraction. So this is one of the very hot future directions in this field. So people now are trying to do aspect term polarity co-extraction. So till now, the process is 2 steps. So for example, so these are all we explained in detail in our paper. So for example, this is the task. Okay, so let's say. So now it is 2 stages. So first is you extract the aspect, and the second stage you detect the polarity. Okay. Now the performance of this stage depends a lot on whether you are detecting aspects correctly or not. Okay, but these 2 tasks are really related to each other. So then we have this new field called aspect term polarity co-extraction. So you model between the relation between these 2 tasks and try to perform 2 tasks together. Okay. Now transfer learning in aspect-based sentiment analysis. What are the works? So we all know BART, ELMO, these things. So when you train BART on ELMO on these large corporas, and you use those embeddings in your aspect-based sentiment analysis framework, that is necessarily transfer learning, right? You transfer knowledge from one model trained on another corpus to another task. So you transfer knowledge from one task to another. Okay, but the models using BART and ELMO for ABSA is very limited. I mean, they are just BART plus MLP, or BART, LSTM, and then plus regression. So we need more work to do on this that explores that how the aspect-based sentiment specific models, not just LSTM, not just transform, you just utilize transform, no, not like that. You need unique framework just to handle ABSA task. Now, this can also be task to task transfer. So for example, you have BART-based networks that works very well for textual aspect-based sentiment analysis, but can you transfer this knowledge to multimodal ABSA, where you have image, where you have image and sound? Can you do that? So these are the works that are still unexplored. I know a group in Singapore working at Singapore SMU, led by Jing Jiang. They are doing work on it, multimodal ABSA. In fact, they have a new data set and new task published in IGCI 2019. You can take a look. Okay, now exploiting inter-aspect relations for aspect level sentiment analysis. So if you can see that how aspects can communicate to each other. So till now, the most of the works, they do not consider the dependency between two aspects. So what does this mean? So in this sentence, we have two aspects. We have this, and this is another aspect. Now, if we do not realize the connection between these two aspects by this conjunction and, it will be very hard for us to predict the sentiment on both of these aspects correctly, because they are connected by and the only sentiment word, opinion word is here. Okay, so this inter-aspect relations modeling is not that explored. We published a paper in 2019, but I guess more work to be done to solve such issues. And doing this also give you explainability in your system, right? That these two words are connected using and they are also connected using this word, this sentiment word, so they share the same sentiment. Such kind of explainability is required. And then of course we need more data sets, okay, and more larger data sets. Basically the semi-val data sets which we use now is very it's very small scale, and if you get a 2% or 3% improvement in the accuracy, really hard to say that whether the accuracy is stable, whether the accuracy is statistically significant, because we worked on this domain and we really found a very unstable improvement across the systems. Okay, so now we move on to multimodal sentiment analysis. So what is that? So multimodal sentiment analysis is basically you have different modalities, and you combine all the modalities to predict the sentiment. So as it can be seen in this example, that you have these three different modalities: text, audio, visual, and you have different expressions expressed by the modalities, even sometimes the conflicting expression throughout the modalities, and your job is to combine these and predict the final sentiment. Okay, so now what are the challenges and what are the new directions in this research? So there are many complex fusion methods available in this domain. So this domain was started, this field of research, actually the field of multimodal emotional recognition started earlier, but multimodal sentiment detection analysis started, I think, 2012 by Rada and LP Morency from CMU. till then, we have a number of new frameworks like TFN, MFN, HiGRO, a number of frameworks to do multimodal sentiment analysis. But in our latest study, what we observed that all these systems perform quite similar to simple concatenation based systems. So when you just concatenate several heterogeneous features, you get almost similar result to these complex systems. Why? I mean, why does it happen? Does it happen because these complex fusion systems fail to model the correlations among the modalities? We don't know. We should explore. In fact, the complex fusion papers, the models should explain this, that why the performance is very similar to the concatenation based approaches. So this is a future work. And there is one more thing that we observe, and recently some of our colleagues from University of Michigan, they also published this research. So most of the times, textual modality performs better than the other modalities, almost always. Why do we observe that? And textual modality always dominates. So very interesting thing to explore. Now, multimodal, now lack of larger data sets. So we have this MOSI, MELD, IMOCAP, but if you see that, compared to the large computer vision benchmarks, these data sets are very limited. Only a few number of videos, only a few number of utterances really make it difficult for the fusion approaches to successfully outperform the baselines. Of course, if you future work. Now, fine-grained annotation. So this is very important. So we, now in AI, we are all after explainability. It's such an important thing to consider. Without explainability, it's hard to believe AI, right? It's also part of the ethical AI. In fact, we have a project in Singapore on explainable AI. Now, the thing is that in multimodal sentiment analysis, we wrote papers, others wrote papers that in such cases, like we saw case studies that if you have textual modality, you get 56% of accuracy. But if you combine all the modalities, you get 61% of accuracy. Okay, great. So multimodality always improves the performance. But why does it improve the performance? What is the individual contribution from the modalities? Can we explain it? Can our model explain it? Cannot. Till now, no, cannot. If you have rules, if you have set of rules, then of course you can. But AI systems like the machine learning and supervised systems, they cannot generate or cannot give you this form of structured rules that says that this multimodality for this sample works better than the unimodals because of the following factors. Okay, so we do not have any data set for that. So maybe we should create a data set with fine-grained annotations, like audio modality has high pitch and other things for positive emotion or anger. There is smiling face for the positive emotion, something like that we should have, right? Okay. Contextual, now we move to the next topic, which is contextual sentiment analysis. Now, what is important here? That if you consider the following sentences, so consider this word big. Depending on the context, big house is hard to clean. Okay, big house is of course good for comfort. Also, the word massive, it changes if you change the context. If you change the context, the polarity of the sentences or polarity of the phrases change. For example, in this case, like carrot, okay, see how this word utilized in two different contexts and having completely different polarity. It sounds like what's the disambiguation, right? This is called contextual sentiment analysis, that you need to rely on the context to determine the sentiment of a sentence. And this is why BART-based systems, Elmo, contextual word embeddings perform so nice. It's because of this. Okay. Now, sentiment analysis in monologues and conversational context. So, like what we discussed before, if you consider this sentence, the bill has been passed. So this sentence is positive. So if you do not consider the next sentences and just rely on this sentence, you can say that it is positive and the user is expressing positive sentence, or maybe neutral because he or she is trying to just explain the fact. Now, if you consider this sentence, I still cannot digest this. This is negative, right? From there, you can track back to the first sentence and can say that on bill, the expressed sentiment is negative. Because although bill is connected to a so-called lexicon, if you consider lexicon, pass is almost positive sentence, but you know, if you consider this sentence, you can infer that on the bill, the user is expressing the negative sentiment, right? So how can you do it? I mean, this is so difficult, right? You need to have co-reference in a different kind of co-reference. It's not really the typical co-reference that you used to do. It's difficult to do, really. I mean, I don't think this has been explored yet. Pardon me if I'm wrong. I mean, I would be very happy if you can point one paper which does this. But this is such a difficult contextual sentiment analysis to do. Like if you have an autoregressive model, or if you have a left to right reader, then you just read from this way, right? And if you do not track back, you don't understand. And you can say that you will use bialistem, but okay, fine, you will use bialistem, but still, how would you make sure that you are properly utilizing, cannot digest this to explain the sentiment expressed on bill? Difficult, really. Okay, so in conversation, it is even more difficult because conversation involves multiple speakers. You have self and interspeaker dependency. Your sentiment can, like, your sentiment can shift from frustrated to anger. Like this is just an example. So this is even more complex. And the applications of this is in dialogue generation. Now you will often hear this term empathetic dialogue generation or affective dialogue generation. So in these cases, this is very important to understand, like the sentiment and emotion recognition in conversations and, you know, like conversational context. Okay, so next, how do we model this context? Okay, in the literature, we saw the usage of RNN transformers, and even far complex model like dialogue RNN, KT, BART MTL that rely on those RNN or transformers networks. But these models fail to explain why and how they utilize context. Okay, they even fail sometimes where the contextual signal is very trivial to guess. I mean, you can have a simple rule to say that, you know, this is positive or negative, but they completely fail to even explain that situation. So yeah, so I'm actually insisting upon the fact that the explainability is required, and I'm showing you the cases that in different situations how you need explainability, from multimodal to contextual sentiment. This is really very much needed to have a true sentiment understanding. An explainable sentiment analysis system must tell us why the user feels that kind of sentence, right? Sentiment reasoning. Otherwise, difficult, really. Okay, next, user cultural and situational context. What is that? So if you consider these two sentences, the person one says the order has been cancelled and person two says that that's great. Now, if you do not really know the nature of person P2, it's very hard to detect whether this sentence is sarcastic or not. If you know that this person is sarcastic, so the most chance of this sentence to be sarcastic. But who knows, that person two might be like, you know, the order is cancelled, it is causing any benefit to person two. If that's the case, then the sentiment is positive, right? So yeah, I mean, these are the difficult things in sentiment analysis. Like if you do conversational sentiment analysis, you need to understand the personality of the user. So this is why Alexa and the modern chatbots developed by other platforms, they rely a lot on understanding users. It's very difficult, and you will probably hear this task called personalized chatbot. I think it's by Alexa or Facebook. I cannot remember, but these kind of competitions are getting very popular because this is really needed. Okay, now there are other examples like usage of okay varies from one person to another, like some considers it negative, some positive, now some neutral, so this like that. Other examples like a hot and sunny weather can be treated as good weather in US, right? Because US is cold generally, but not in Singapore, of course. We always need to use air conditioner or fan here, always. Yeah, so these are the user cultural and situational context. So context can have two forms, two forms. One is the context in the monologues and conversation, and the another is the user cultural and situational context. Okay, now a very interesting thing, the role of common sense knowledge is sentiment analysis. So we all now live in an era that is day by day going towards common sense reasoning applications, tools to perform common sense reasoning, because we understood that you cannot achieve everything with the contextual word embeddings, or probably you can achieve many things with more things with contextual word embeddings if you inject common sense knowledge to this word embeddings. So this is one kind of example. So if you see the sentence, David is a good cook, he will be making pasta for us today. Now from this sentence, what can you infer? What knowledge can you discover? So from good cook, you can discover good pasta. From making pasta, you can think that the ingredients that the ingredient is available, and we are making David is making the pasta so that the people can eat. Okay, so these are the knowledge discovery. These are the new kind of knowledge that you can extract using common sense reasoning from a sense. Like we human being can do it easily, but for machine, it's so hard to. I mean, can you imagine we have a machine that we have an artificial intelligence system that can extract such nice common sense knowledge for us? That will be amazing, no? Of course. And of course, I mean, as you can see that once you have such extra knowledge, you can train a better contextual embeddings, and you can even infer sentiment knowledge, like a good cook is expected to prepare good pasta. Okay, next slide. Now, role of common sense knowledge in sentiment analysis. To explain that, I mean, like in continuation with my previous slide, if you consider this example, we have not seen the sun since last week. Now, in this sentence, what can you see? For a system, without having common sense knowledge, it's so hard to correctly classify the sentiment, right? Because it looks like neutral. Like for a machine, it looks like neutral. We are human being. Sunlight is good for us. We all know. So using this extra knowledge, we can say that not saying sun since last week is negative. So these sentences are really difficult to process. And in a chatbot, if you I mean, think about this. You created a conversational system to help them to help the patients like who are suffering from mental health. Okay, now the patient utilized the chatbot, empathetic or effective chatbot. He or she wants to spend good time and wants expect some empathy from the chatbot, and just write that we have not seen the sun since last week, and the chatbot replies, okay, that's interesting. Not a good response at all, right? So we need to understand the sentiment in such sentences and why this understanding is really needed in a chatbot, in a conversational systems. Okay, now sentiment reasoning, very interesting topic and one of the most important topics in sentiment analysis. So first is you need to understand who the opinion holder of the sentiment. For example, if you consider these two different sentences, the movie was too slow and boring. And the second sentence is the movie to be slow and boring. So in these two sentences, if you consider the speaker, the first in the first sentence, probably you are the speaker and you are showing your own sentiment, and but in the next sentence, you are probably explaining someone else's opinion. So this is why understanding the opinion holder is very important, and it's not a trivial task to do. Okay. Next is why this is why this is not a trivial task to do, because we are now working on a news corpora where we need to extract the quotations by the speakers, and you need to really do co-reference analysis and things like that to extract the quotation and opinion holder. Okay, it's not that in every sentence you will find subjects like this. Okay, now why, like the why someone expresses the sentiment, very important to know, right? Consider this example: I am sorry that John went to prison. Now in this sentence, if I ask the system, tell me why am I sorry, the system should infer that John went to prison, and go to prison has negative implications on the actor. Okay, so went to prison, this is negative for this person, and I am sorry for this person. Okay, so I am sorry because John went to prison, and went to prison is negative. So this kind of sentiment reasoning is rudimentary in this field. Okay, and really in last year, I remember there was a very nice paper in EMNLP, I guess, or in ACL on emotion cause extraction. So the task is similar to that. So this is a good sign that people are slowly moving towards that extracting the cause, understanding the reasoning behind the sentiment, but we're still far from that, from achieving any fundamental developments in this field. If you can see this example as well, you need to understand that Chandler's deception actually, created the anger for this person. Okay, if you go through this conversation, you will understand this. So this is why in conversational context or in monologues, understanding sentiment and the reason behind the sentiment, extracting these things are so important. Okay. So what are the main challenges in this? So this is a hard part of hard task, but what are the other major challenges? So the main challenge is the unavailability of the fixed taxonomy. There is no taxonomy that can define sentiment reasoning. Okay, so a future work could be building such data set. You build a data set, you come up with a taxonomy, you annotate the data set with that taxonomy. That will be a very nice data set to explain the idea of sentiment reasoning. Now, next task is about domain adaptation. So what is domain adaptation? You simply train a model in the source domain and you adapt that model to the target domain, and you do not have any knowledge about the target domain. Okay, so this is a sub problem of domain generalization. So what is domain generalization? In simpler word, you have a you train a model on a domain, and you can apply this model successfully on many other domains with some good results, with some good performance. So the key methods in this domain adaptation is domain adversarial neural network, DNN. We probably most of us know about it. So what does it do? It basically, you provide a document, and then you have two tasks. One is you classify the sentiment of the source document, and you classify, you discriminate between the source and the target document. Now, to learn a domain invariant representation here, you try to make this discriminator weak. Okay, so you try to make this discriminator weak so that the model relying on these features does not have the ability to discriminate between domains, that means domain inferent representation that it learns. So this is the DNN. It works fantastic, right? We all use it. Now, how can we improve it? Use of external knowledge. So as you can see in this example, so if you have a structured knowledge like this, and these are the different domains. So this is books, this is electronics, and this is the DVD. These are the three different domains. And if you can see that using this relational knowledge, and this bridge, the domains are connected, the domains are interconnected. Can we somehow utilize this representation in our network? We recently worked on this paper called Kingdom, accepted at ACL. It's my PhD student Dipanoy and Dev's works. So what we do, we take ConceptNet, we filter the seed concepts from all domains. So for example, we have domains, we extracted noun, adverb, adjectives, and we create a subgraph based on it. Okay, so this is the domain aggregated graph. So we have a whole graph for source and target. Now from there, we do graph convolution neural network. We have an edge prediction algorithm, like it's a graph, it's an objective, like you predict the edge between two nodes, and we learn the embeddings of the nodes in the graph. Now, in the domain adversarial training, we just utilize the features from this graph. So as you can see, so this is the regular domain adversarial training, and these are our extra features that we utilize. Okay, so you utilize these features for that in the domain adversarial training using just one extra objective, that is you reconstruct the graph features. Okay, so this simple setup helped us to outperform the strong baselines by moderate margin. For more details, just read this paper if you have time. Okay, now scaling to many domains. So in domain adaptation for sentiment analysis, most of the systems, what they do, so you provide the source and target domain, like you provide this pair and ask to classify, to train on the source and evaluate in the target. But this needs you extra source target pair for every domain pairs, which is not possible in real life, right? We need we can have multiple other domains which are not labeled at all, and probably you will not have many data for other domains so that your training is successful. For example, in this domain discriminator that I showed in the last slide, you need data to for the domain discrimination. And for example, I give you a domain name for which you do not have enough data. So what do you do? So that is the task of domain generalization, and not many work's been done on this topic. Okay, now moving to the multilingual sentiment analysis. Prof. Emily Bender, she has a rule on this, and it's a very popular. It's called Bender rule. And what does it say? That whenever you are working on something in NLP, you should always mention the name of the language. That is, if you work on English, mention that you are working on English language, which is necessary, yeah, I mean, we are stupid not to follow this, but we should follow this. I mean, see, I mean, there can be language biases, right? For example, you develop a system that only works on English language, that does not work on other languages. That is, I mean, we should always mention that these data sets are in English. This method we tested on only English, not on other multilingual data set, if you don't perform that. Okay, so yeah, you can read her tweets, you can read this paper by her to know more about it. Yeah, this is a really important work, and this is very important in the context of multilingual NLP. Okay, so we move to the language specific lexicons. Now see, there are some lexicons in sentiment analysis, some rule based systems, like whether these systems were great for English language because of the availability of the data. but but what about the other languages? I mean, Hindi, French, Arabic. I mean, these languages, not so much data are available, not so much lexicons are available, so that you can create such kind of rule-based engines for sentiment analysis. So this is a problem, and it's not only for sentiment analysis, for many other NLP applications, because of the unavailability of the data. You would not see much progress. So I remember Pushpak Bhattacharya's group from IIT Bombay. They created this Hindi wordnet, which helped a lot to towards the progress of natural language processing in Hindi. So yeah, so we should make conscious effort towards multilinguality of sentiment systems. So then sentiment analysis of code mix data. So if you can see this example, like this is a Hindi sentence written in English font. So in this sentence, we need to, this is a mix of Hindi with Roman orthography, and the rest is in English, right? So yeah, so this is a code mixing problem. It makes the deep learning models trained on the English data very difficult to perform well. So how can we overcome this challenge? Probably we train a language model on code mix data. I think there are some papers doing it. I'm not so sure. Please do check, and if not, if nothing is there, let's do it. And the challenges is how and where we mix the language is really, that really depends on the person's own choice. And then deep compositional semantic that lies in the code mix data. Like, you know, you need to analyze, you need to have a model that understands Hindi, you need to have a model that understands the English. Then you need a model that links these two languages. So it's very complex than we think. Okay, very important topic. Now, sarcasm analysis. Leveraging context in sarcasm detection. I will be slightly over time. I just have one more topic to explain, I guess. So leveraging context in sarcasm detection. So if you consider this sentence, he sure played very well. Is it sarcastic? If I give you a factual context, the team lost yesterday. You can guess the context, right? It is the factual context. If I give you the conversational context, I never imagined he would be gone in the first minute. So based on these two different kind of contextual utterances, we can guess the sarcastic nature of this sentence. So in sarcasm detection also, contextuality matters a lot. Now, we used LSTM, transformer, doc2vec, such kind of models to model this context. But in my personal experience, like if you read our paper Cascade, and if you read paper from other groups, you will find that contextual models do not really improve the result of sarcasm detection much, like very little improvement. Why so? We don't know. We really need to do research on it. Now, this is the multimodal context. So in multimodality, we recently published this data set called Cascade in ACL 19. So if you see this data set, we provide many examples where the modalities are incongruent. So what is that? So text data represents different emotion compared to other modalities. Okay, so they are conflicting. One modality conflicts with another. So this kind of sarcasm detection in multimodal context is very underexplored. I think just 3 or 4 papers are there and a lot to do. Okay, great. Now there is another challenge in the annotation of the sarcasm, like intended versus perceived sarcasm. What is that? That is, sarcasm itself is very difficult task for us to, sarcasm is a difficult thing, right, to understand, to perceive. We often miss the sarcasm. Like if you read the memes and Reddit, if you use Reddit too much, you will really, yeah, I mean, I find it very difficult to detect sarcasm easily. So there is an annotation. This is an annotation challenge, you know, like how, like whether the user intend to express sarcasm and how we perceive sarcasm, there is a huge gap, and that affects the annotation quality. In fact, in our dataset master that we published last year in ACL 2019, we faced this challenge. It took us 2 years to develop the dataset, which contains just 500 utterances. Can you believe it? Like just 500 utterances, and it took us 2 years to properly annotate it. It's because to make sure that the annotation is of good quality. Okay, and it's also a multimodal dataset, so we had to actually annotate for 3 modalities: audio, visual, and text. So 1,500 samples, you can say. But yeah, indeed, a very difficult thing. A solution: self-annotated data collection that we do often, like Twitter hashtags or Reddit sarcasm subreddit. So these are the things that we can try to do to achieve some good data collection. But again, I mean, this is not possible when you have a conversation, right? You have a multimodal or real conversation. Very hard to do. Okay, now target identification in sarcastic text. So this is a new task developed by Aditya Joshi, when he was a PhD student at IIT Bombay with Puspak Bhattacharya. They actually brought this new task. So this is important, that in sarcasm, who is the target of the sarcasm, on who is we are expressing the sarcasm, right? This is important for chat-based systems or aspect-based sentimentalist tasks to assign the sarcastic intent with the correct target in general. Otherwise, you will mention others' name, anyone's name, right? The challenges. What are the challenges? Now, in expressing sarcasm, we often implicitly mention the target of our most of the times we do not explicitly mention the target on which we express the sarcasm, or we just ignore. I mean, or we just mention it somewhere in the text if we write a long monologue. So understanding the target of the sarcasm is not a trivial task, indeed a very difficult task, and only little work has been done on this. Now, style transfer from between sarcastic and literal meaning. My friend Tuhin from I think he's in Colombia right now. He worked on it, like generate sarcastic text when style transfer between sarcastic and literal meaning. He utilized some rules and common sense knowledge to do it. So here is an example. Like, I loved sweating under the sun the whole day. Can you convert this sentence to I hated sweating under the sun the whole day? So that means you detect the sarcasm correctly. You not only detect that, you actually try to understand what is the word that is creating sarcasm here. That is the loved, right? Now this is a very easy example, and this is why the rules work. This is an example where there is a sentiment shift, like sweating under the sun the whole day. This is of course negative, and you cannot love this fact. So this is a sentiment shift, and using this signal, you can have a rule and can easily flip. You can easily transfer the style from the sarcastic to literal meaning. Now, this is not true for most of the other sarcasm types, where the sarcasm is very implicit, where you need to know the contextual context to detect sarcasm. But anyway, just to show that this is a very, very interesting task. It can help in data augmentation. It can help in generating adversarial examples for both literal and sarcasm tasks. Like, you can have a lot of parallel data for style transfer, and vice versa. Like, you can generate sarcasm from the literal meaning, like my friend Tuhin did. It will be like, it has a brilliant application in the field of conversational systems, like part of computational creativity. Okay, now sentiment-aware natural language generation, another important topic. So it has two subtopics. One is the conditional generative models, so, and another is the sentiment-aware conversation generation. So conditional generative model, so what it says that we human beings, we count on several variables: emotion, sentiment, personality, topic, global knowledge, intent, a lot of things, right? So if I just give you bunch of parallel corpus, source to target, and I ask you to train a sequence to sequence network, do you think that sequence to sequence network is enough to create exactly perfect responses? Impossible, right? If you do not leverage on emotion, sentiment, personality, topic, global knowledge, intent, like if you do not count on these variables, it's impossible to generate perfect responses using the sequence to sequence network. You need to create different models or different architectures to encompass all of this. So what are the possible or existing approaches? So learning disentangled representations, like you separate the textual content from high level attributes such as sentiment or emotion or tense. And there are works like GANs, VAs, using VAs to do that. An alternate method is there, which is attribute to text translations. Like you have the attributes model in the hidden layer, and based on that, you condition upon the decoder to generate the desired text. Okay, this is still very new topic, and people are trying to doing it. And this field also involves some style transfer. Like if I give you a conversation where a person who is angry generates a response, but a person which is generally calm responds with another reply, right? So this kind of applications are there. Now, what are the challenges? So, of course, as I mentioned, that it requires parallel data, which is unavailable. Attributes might not be available in desired format, like, and you need a taxonomy of the attributes. Like attributes can be some descriptions, attribute can be some personality, attribute can be some background information about the users. I mean, you never know. A very early stage. I mean, this field is at very early stage, like sentiment aware natural language generation. Okay, so the next is sentiment aware dialogue generation. As I mentioned, this is a hot topic. Okay, so similarly, I mean, simply what does it mean? That in the basic sequence to sequence network, you learn the sentiment automatically. I mean, at least the assumption is to learn the sentiment automatically from the text, but most of the times it does not happen. So you need to have a sentiment specific model that grasps the sentiment information to generate corresponding responses. Now there are these works like ECM which does that, but it suffers. Like we tested it and we found that it failed to generate consistent, meaningful responses. Okay, even if you change the emotions of sentiment, it generates the same responses many times. So possible solution: you create better emotion modeling algorithm or a better conditional decoder. Like this is the model. This is the model that we proposed recently. It's a conditional model for dialogue generation, where you condition on topic, condition on the personality, condition on the intent, user's previous contextual utterances. Then with that, you form a speaker state, speaker's internal state, and emotion state, and binding all together, you generate the responses. This is a kind of probabilistic model that we can try to do to achieve some generation. We recently submitted a paper, considering this model. I will share later maybe about that. Yeah. Then sentiment or style transfer, similar to the sarcasm style transfer. In this sentence, the chicken was delicious. Can you convert this sentence to this? But the delicious should not be converted to rude. Why? Because they are of course not comparable, right? Not compatible, right? Or not comparable. So we have to learn word sentiment associations for such style transfer, right? Now the final topic: bias in sentiment analysis systems. So we recently saw a huge Twitter debate on the bias in machine learning or bias in NLP. So let's just discuss it in the context of sentiment analysis. Now, bias can be introduced in a sentiment analysis system in many forms. For example, bias in word embeddings. So if you train word embeddings on Wikipedia, recently a study covered that 15% of contributions to Wikipedia, only less than 15% of contributions to Wikipedia come from women. So naturally, if you train on such a corpus, like underrepresent, it will underrepresent women's point of view. And bias can also cause from the systems, like your system architecture. You design the system architecture in a manner like you include the demographics, gender, race, nationality, geographical cues. Or I work with some banks, and they utilized the gender. So all these things can cause problems in the sentiment, in the architecture, right? And the model architecture, it can actually amplify the bias that you observe in the data. So suppose you create a Twitter sentiment analysis system, and I utilize the gender, the race, age, and I provide you some samples which do not, which represent the which carry the underrepresent part of your training data set. Then what will happen? So your model should not utilize such factors, right? So what could be the solution? We can develop culture specific sentiment analysis models rather than creating a generic one. Is it a solution? It's computationally not possible, right? Now, identifying causes of bias in sentiment analysis system. So now we can have bias in the training data as well. So for example, if you have frequent co-occurrences of a sentiment phrase with a particular gender, that is the bias in the training data. And that means that you need to design your system in a manner that should deduct this bias that you see in the data. So it is your responsibility to design your architecture in a manner, and you cannot be just blind and train your system on the whatever data you have. It's your responsibility as a data scientist to design your architecture in a way that it encapsulates all these things that are there in the data set and try to take the necessary actions. So other examples include over or under representation of a particular gender with training samples, strong correlation between a particular demographic and sentiment level. For example, female subjects frequently belonging to positive sentiment category, that is there in your data set. So in your model, you need to plan, you need to build the architecture in a way, you need to model the feature space in a way that you subtract, you deduct all this information. You cannot neglect this, right? Now, author stylistic sense of writing. For example, one person uses strong sentiment words to express a positive opinion, but prefers to use milder sentiment words in exhibiting negative opinions. So if you have such cases, you will have, of course, bias, right? For example, like for positive, you will have strong positive score. For negative, you will not have that strong negative scores, even if you intend to express negative, even if you intend to capture negative opinion in the input, strong negative opinion in the input. Okay, and now evaluating bias. So detecting bias is easy because you can create the samples, you can test the samples using a machine learning framework and see that whether for male and female, for when you change the race, they generate the similar output or not, whether you observe the similar trend or not. But how do you evaluate this bias? It's difficult. There are some corpuses which does that, like this EEC corpus, emotion equity corpus, but they are just template based, so it's not really scalable and it does not cover many sentences, many examples. And if you consider these examples that I gave, where multiple genders are present, it poses a great challenge to evaluate the gender bias or evaluate bias in general. Now, how do you debias? Of course, debiasing is difficult, even more difficult now, and only few research works along this direction. The common work the common word that exists in this field is you perturb a text with word, like you substitute one word and you perturb the text using that, and you generate the counterfactual cases. Now you probe your model based on those cases, and you try to fix the embeddings, like you try to find a gender direction or find a bias direction, and try to do some linear algebra stuff to remove subtract bias from the embeddings. So these methods are there, but not really much research have been done. Even in the context of contextual models, very few research have been done. A paper I remember from 2019 SEL that did this on Elmo and evaluated on the co-reference resolutions. Like if you have gender stereotypical words and you try to see that whether the stereotypical words mostly refer to gender male or gender female. Okay. So they try to evaluate on that corpus, but very few works been done in this debiasing thing, like how you extract a good gender direction and things like that. Yeah, so our statement regarding this, that like bias can also exist at a higher level when making research choices. So the tendency of the community to resort to English-based corpora over the multilingual corpora. Such trends diminish the research growth of marginalized topics and study of arguably more interesting languages, a gap which widens through time. You can read this recent paper by Hovey. And as a community, we should make conscious choices to help the equality of underrepresented communities within NLP and sentiment analysis. Okay, so bias can have many forms. Bias can be, it can be gender bias, or it can be bias of our research choices. Okay, we should not ignore the underrepresented languages, underrepresented, unexplored research territories. We should always explore those. Okay, we should not bias our choices. Okay, that's all for today. Thank you very much.